We're going to be doing the full build from start to finish of one of my Jimmy's Moonbuggy projects. This project's based off of the project that I've got listed on my website, where you can download all of these parts that we're showing in the 3D print, and then you can build this yourself with these bend templates and jigs. As we start with these, each tube has a template. Now, what I'm doing there is the template is not just a bend template, but for this one, it's a length template. I'm using solid rod for these rockers. This is the third one of these chassis that I've built, and each one has been a little different. Now, tubes that do need bends, they come with a bend template, which I'm holding there to the side of the bender. This allows me to gauge how far it needs to be bent, and then after it's bent, I can pull it out of the bender and lay it into that bend template to make sure that everything is perfect. After you've got the bend perfect, you cut it to length with that same template. The front bumper on this is designed to have bends at each side, but I'm deciding to use a solid front bumper this time, different than I have the previous two times, and I'm not going to bend it. So I'm just cutting it to the length of the bent bumper, but not going to add that. You can make small adjustments to this however you like. It just gives you a really good base to do so. With the solid, I am putting a little bit of chamfer on the end and then just smoothing it out. Each tube gets dropped into the fixtures and zip tied in place. The rockers on this line up with the back edge of the fixture. That's important for the length, and it actually comes into play later as well. Same as the front bumper, getting everything zip tied in place. Now, as tubes need notched to match into, this just takes a little bit of fitting and finishing. I use a Sharpie to mark how the actual notch needs to line up, just giving myself a reference mark. This whole build, I'm using a 3/16 chainsaw file to do all the notching. I do have a much more powerful notcher that goes much quicker, but you don't need it. It doesn't take that long to notch by hand, and that's how I decided to do it in this build. After everything's notched, I'll just clean it up with a file and a sanding pad just to keep all the little stragglers clear. I'm using the YesWelder 205P Pro. I did change out the actual torch on this, just an inexpensive one off Amazon. I actually changed the torch twice during this build. Now, since I'm not using the button on the torch anymore, I am using the YesWelder foot pedal. My settings for tube work, specifically 3/16 with an 035 wall tubing. I use a 35 peak amperage. My pre-flow gas, I actually use 1 second. I go back and change that here. And then I am using the pulse settings. So 35 is my max, 10 is my base amperage, and I'm setting it to 2 hertz, so 2 pulses per second. And 50%, so it's just base voltage and peak voltage or amperage back and forth 50% of the time. You can change that percentage if you like. Then I use 4 seconds of post-flow gas. When you turn your argon on, make sure you turn the bottle all the way on until it's fully open. Proper PPE is key, specifically TIG welding gloves, as they give you a lot more dexterity. Ground clamps on these are often large, and for our type of tubing, especially in 3D printed fixtures, can be a bit of a pain. So I pick up these generic ground straps from Amazon, bolt it onto the top clamp there. Then it just allows me to put it in place, and it's just a lot more flexible. I'll tack weld everything in the fixture. More than a tack, it's kind of just welding one side, but trying not to put too much heat to where it actually deforms the fixture, just to keep everything in proper alignment so that I'm not getting any, tweaking of my tubes before I take them out. I'm using 1/16 silicon bronze filler wire. This is technically TIG brazing, not TIG welding, but this is a huge, huge benefit to TIG welding, and it makes things so much faster and more reliable in these type of fixtures when you use silicon bronze. After everything's welded on one side or brazed on one side, cut everything out and remove it completely from the fixture. Only use PLA when printing these fixtures. If you use anything else, it'll have a tendency to stick more to the tubing. You just want to use generic PLA. It melts a little bit, but it comes off clean and it brushes off super easy. Just keep it simple. After you get it out of the fixture, you just got to fully weld up those tubes. I use a wire wheel in my drill press to just clean everything up. Super simple process. You can do it with a regular wire wheel by hand. You can do it with a drill. You don't have to use a drill press. It's just something handy as it frees up both hands to maneuver it around. This is the end of stage 1 of the project. This goes into the second set of fixtures from here. Each of the bend templates has some raised lettering on it. I use a Sharpie and just kind of go over the top of it. You could also use the AMS of a bamboo printer to help get that printed in separate colors, but I just keep it simple and do it with a Sharpie. This is a miter jig that I had made for the front. There's a number of different options on how you can build things in this project that are all included in there. I decided to use solid rod at the base of the windshield. I don't know if I would do this again. It definitely required some more heat, but it was a little bit more forgiving in some ways. You know, like I said, I built 3 of these so far and each one's been different. This miter jig has got these little recesses in the corners, and that's made to help you actually cut the tubes so that they perfectly miter to each other. You have to make sure that you do leave some tolerance so that when you cut it, you have room for like the blade width that it takes off. So you need to kind of push it past when you do the second bend or second cut. The other side of the tube will be the complementary angle, so you can use it and then just cut it to length. I'm using this template to get everything tacked into place. Just putting it right back in there and putting a small tack in the very top of the tubes. You can see here I have the different torch back on. This torch uses the same size gas cups that came with the 205P Pro. After welding in the jig, I just cleaned things up with my chainsaw file just to, if there was any deformation from the welding process, just allows everything to drop back in nicely. From here I need to cope the 2 tubes that come back along the hood bar to make sure that they fit nicely with that new windshield bar. I decided to take this windshield bar and carry it past the edges. It's just a difference in style, not necessarily a difference in performance or anything like that. Once everything fits down nicely into that fixture, I knew that I could get it welded up. These are the printed stage 2 fixtures. The finished component from stage 1 drops in these, and then you assemble the jig halves inside of it. I also decided to use a solid rear bumper bar on this, and I decided to make it the length of the mitered rear. Again, this isn't a super important decision because later on down the road I will need to trim it to length. I just left it a little long at this point so that I was sure I was going to have proper area for the tubes to all come together on that. This is the only or the most difficult bend on this cage. I had this piece of tubing that was just long enough to accomplish this. So I made sure that it would be the right length. You can see I have very little wiggle room on each end. I recently released a tube bender for people to access in an easy and affordable way. This is the same method that I show in that video with how to bend. Calculating a setback distance and using that as a datum on your bender to make sure that you can get repeatable bends. This bender has a larger distance. My new bender has an 11 millimeter setback. So from where the radius starts, you measure 11 millimeters back, and that's how you know where to put the tubing in the bender. Doing this method gives you the proper amount of tubing so that it doesn't move on you. You know exactly where it's going to be and where it's going to stay so that you don't have to guess at how your bends are going to come out. You can also see at this template, the two bends are not in the same plane, which you do need to pay close attention to. You need to make sure that you line that up. Using the printed fixture as a guide to make sure that everything's lining up is the best way to do that. By using that method, you can have a perfectly bent, complex tube without any guesswork, and you have the exact same amount of hangover left there at the end. You can see there's two different options for templates here for that rear section, that rear belt bar. I used the mitered length for the rear tube, but I wasn't mitering them together, so I'm actually just going to use the standard rear belt bar template. Again, these are just small differences of choices you can make as you're building. The templates make this very easy to find out exactly how or what you want to use while you're doing this. The B-pillar is almost symmetric, but it does have one side that's slightly longer than the other. The lower side is the slightly longer portion, so you just need to make sure that you pay attention to that. It's a small thing, and it's even if you don't pay close attention, it'll still work out, but if you do it right, everything just fits into the jig a little bit better. Here, I'm determining how much I need to miter that lower tube so that the top portion sits about halfway on the tube that it's crossing. That's just so that I know that I've got it, centered properly in the design. The B-pillar tube interacts with a lot of other tubes, so you actually need to go through and get it coped as well as the others and keep going back and forth, making sure that everything fits before that you decide to actually weld anything together. Just a little bit of a puzzle. Keep going back and forth until everything properly fits, and then you'll go through and do your welding. There's a rear extension to the rear portion of this fixture, just to make sure that you can get the alignment of that rear belt bar proper. Without it there, you don't really have the ability to control the rotation and know that you have it in the right position. The reason that it's removable is because it's so close to that joint that if it was just there, it would instantly melt. So I made it removable so that you didn't melt the fixtures as much. Where the A-pillar comes down, it not only interacts with that windshield bar, but also the bar that's right there at the top of the door area. So you also need to get it notched on the bottom portion. That's what I'm doing here. The rear portion of the C-pillar there is the longest cope in this entire build, so it takes a little bit of work to get everything to fit properly in there. I decided to make a little fixture to help me with the coping. I was using a sacrificial piece of 1/4-inch plate on top of my bench just to not make a bunch of file marks. I made a 3/16-inch hole through it and cut it very close on the bandsaw, and I just TIG welded it in place. This just holds the tube right flat on the plate as well. That way I didn't have to put pressure down with my fingers. This is just a simple little mod that saved me some pain. Now I'm removing this top bar just so that I can get to the joints better, especially at the windshield area and then at the very rear as well. Welding areas with the solid rod where the tube meets is a little bit more difficult. One of the reasons that I maybe wouldn't do that again. You do go through a lot of zip ties in this project, but using zip ties is very helpful because you can actually put some force on them to get a tube held in place properly. Lesser clips or reusable type items just don't have that same function, so just pick yourself up a good sized bag of them and plan on using them up. Fitting tubes into the jigs just takes patience. Here you can see that it's not quite fitting square. It's slightly pushed down to one side and up on the other. So just meant I needed to take it back out and take a little bit more off. Once everything from the stage is welded on the front side, it's just a matter of disassembling the entire fixture, cutting all your zip ties, and breaking the jig out from the center of the welded parts. Everything will come out through the actual center. Since it's held apart with the braces, once those are out, everything will slide in and then down. That's all of the stage 2 tube work. So now we're just going to clean it up and get it ready for stage 3. I am liking this 205P Pro from YesWelder, so I decided I wanted to put a gas lens on it. This is from Furic. This is their FUPA cup. At this point, it comes with a 3/16 inch mesh made for a 3/16 tungsten. I'm running 1/16 tungsten, so changing out the mesh, putting on the clear glass Pyrex cup, then using a gas lens on the inside rather than the diffuser that comes factory with the YesWelder and this torch as well. YesWelder also uses that long style collet there, which we're going to go to a wedge style collet on the inside. This isn't necessary. You will use more gas with this as well, but you do get more gas coverage. It's also a little bit shorter. It allows you to stick your tungsten out further, so if you are trying to get into a tight corner, things can be a little bit easier to get to. This is the wedge style collet. It doesn't have the slit in it like the normal ones do. When you tighten this down, it just kind of wedges things off to the side. It doesn't wear out over time like a split collet will. It's a simple style. Then I'm using a super stubby rear cap. You do have to run a shorter tungsten to accommodate that, but it keeps your whole torch setup nice and slim. Now on to stage 3. This is all the printed parts for stage 3. It's much smaller in total than stage 2 is. Stage 2 is definitely the most involved portion of the build. There are some tubes in the chassis that do not have fixtures. These specifically are 2 of them. They're just a super tight area, and getting any fixture in there would be almost impossible just because of how quickly it would melt. While you could fixture it, it just wouldn't hold up. So it just takes a little bit of handwork. One of the very few areas on the chassis that is done that way. I used a couple of magnets there in the top corner so I could attack down on the bottom side. Magnets can affect arc and things like that, but it's not something I've noticed as far as actually being a problem. So tack it on one side, pull the magnets off, tack the other side in place. This is the sheet of laser cut parts that are used on the project. They're all done on a big tree to keep the cost down. So from there you just go through and cut them all off, whether you have a bandsaw like this or a Dremel cut-off wheel, whatever it is. You're just gonna have to spend a little bit of time getting them all cut free. With the laser cut parts, it does help to go through and just clean up the side where the laser actually punctures through, and on the back side as well, just to get that little hard slag area off, especially before tapping the holes. It doesn't take much pressure. From there, just using a little bit of tapping fluid. There's M3 and M2.5 holes on this. Now, the M3 holes are the larger holes, obviously, and the 2.5 are the smaller. It should be pretty easy to tell. There are some holes that don't get tapped, but those will be, if you did run a tap through them, you wouldn't hurt them, but you also wouldn't cut any threads. All of the body panel holes are done with M2.5. This allows you to use a smaller, cleaner hardware, and since you don't have to weld on body nuts with these, it's much easier. Most people have to use M3 just because welding body nuts on would be much harder with M2.5, but with the benefit of how we do it on this project, it keeps things easy. Decided to make a little modification to my ground strap, so I cut the strap and then used an alligator clip and got it attached to there. Simple little thing, flows enough amperage for the type of tubing that we're using. Obviously, this would not be appropriate if you were doing anything with high amperage. Now, the lower cradle, the pieces are not exactly symmetrical, so there's one way that they go together properly. Just pay attention to that and make sure you build one direction and then the other mirrored version of it, so that when it gets put into the chassis, everything sits equally from left to right. I get these tacked in place, and then I'll run a bead all the way down. Dip my tungsten in there. Happens on occasion. Less and less as I practice more and more though. I'm an amateur welder at best. This is not a welding how-to. This is just showing me welding. So don't take what I'm doing as the proper way. I've learned through trial and error, and YouTube is all. The body nut tabs do not need to be fully welded on. A couple of nice tacks, 2 or 3 even, is pretty much all you need. All the laser cut parts should drop right into the tubing, but if they don't and you need to do a little bit of grinding just to make everything fit flush, do it. It's not a big deal, and the bolt pattern will still be as it's designed, so all of the later parts will still fit as long as you don't have to get into any of those holes. I did miss the portion of the video where I actually welded that roof panel in, so you see me using the wire brush to clean things up on the inside, but you didn't see me actually get that welded in place. This is the fixture for the subframe and the rear firewall area to be mounted into the chassis. The subframe pieces will bolt to this lower cradle portion, and then that will align with the back side of the rocker so that it sits in the proper position forward to backward. I do recommend printing 2 of these jigs just because these can melt slightly and you still have to do the firewall portion. You do want to get those subframe sections welded in as completely as possible. There is a lot of force that will go through this area, so it is good to have those put solid onto the chassis. The rear firewall section, again, this mounts via that cradle, so you want to make sure that it's in place properly, and then you want to make sure that it fits down and lines up with the holes in there. This will play together with the transmission setup later down the road. Make sure that everything fits properly and that you're not forcing anything or putting it at an odd angle. The shock mounting fixtures are a little bit tricky. You want to get the tabs held in place and use the shock pivot ball in between the 2 tabs. That should be an 8mm pivot ball. Once you've got one side tacked in, the far side, you'll want to get it all disassembled, take the jig off, and then reassemble it with the shock tab and the pivot ball and a lock nut so that you can then tack the other side in place. You can't tack both sides of the shock tabs with the fixture just because, again, the proximity to 3D printing just doesn't work out. The front laser cut portion has a tolerance that's noted in the build package. It tells you how far back it should be from that front bumper. The laser cut portion that goes on the rear engine bars also has a dimension that's listed in the build package documents. So again, these pieces don't need to be fully welded like the subframe, just a few nice tacks along the edges. And that does it for the actual chassis fab. From here, we get on to finishing the build. This build's based around a Vanquish VFD twin that gets modified so the top shaft actually goes the opposite way out of the transmission. Gives you the ability to have rear dig and front selectable overdrive, or you can do some modification and get front and rear dig out of the transmission. I'm using machined transfer case gears with this build, and then I'm also using the slipper eliminator setup. That's sold separately, so you will need that piece. I'm also going to be using the lightweight gear set, but I'm only going to be using the bottom gear specifically, and I'll show you why here in a little bit. A top shaft for this build is available pre-machined. You can modify the stock top shaft that comes with the VFD twin just by cutting it, drilling a single hole. It's not that big of a deal, but if you just want to buy it complete, it's on the Vanquish website. You need to drill out the top portion of the front section of the VFD twin. This isn't anything precision, you're just trying to make sure that the top shaft can clear through. I do a pilot hole first, and then I'll go through with a 1/4 inch drill bit roughly to get through there. It does have a tendency to want to walk down a little bit just because it drills right through on an odd slope. So you may need to clean that up with a file just to make sure that the top shaft doesn't rub if it went slightly sideways. We're installing that top shaft that is sold separately, putting the bearing on, the pin, and then I'm using the stock sintered top gear. And that's because since we're flipping this around with the top shaft, that lightweight gear would actually go the other direction and you wouldn't get good contact area between the lower and upper gears with the lightweight gears since they're so much thinner than the factory ones. But the lower gear is where you save most of the weight with those lightweight gears, so you're still getting a huge advantage. The rest of the transmission builds pretty much like the instructions state, so nothing too tricky as far as that goes. Now I'm only putting on the front section of the transfer case gears, and that's because I'm not going to be using the selectable overdrive. I'm going to be modifying the transmission to have front and rear dig. I'm using a prototype piece to get the rear dig set up. The VFD twin transmission comes with front dig standard, but the rear dig just takes changing out one of the bearing plates. Again, this is just a prototype part that I had done here, and it's metal 3D printed in this case. I don't use the gaskets on the VFD twin in this type of situation just because I'm not expecting to get into that much, loose dirt and things like that, like a trail rig possibly would. So I just don't worry about it. It doesn't hurt anything to use them. It's just a laziness thing. I won't be using the gearing that comes with the VFD twin. Since we're using the slipper eliminator, I'm switching to the standard 56 tooth spur gear that's used on the other VFD transmissions. You can use a 5x10 bearing. This will help you get the spur gear centered properly onto that slipper eliminator and not have any sort of out of round type use. I just put on the little aluminum spacer that's included. Also, you do need to put a button head in the lower screw on this to make sure that it clears the skid plate that comes with the package. This is a machined version of the skid plate that Brazen Scale sells. There's a 3D printable file in there, but the machined Delrin one is so nice. Now I'm using this 5x11 flanged bearing on the top shaft there. This will be retained by the motor plate that goes in here. Now I did put on that spacer that was used in the VFD previously, but that actually does need to be shaved down. I'm just using the top plate there to determine how much I need to actually take off, and then I'm going to just disassemble everything and sand that spacer down until it gets to the proper thickness. A little over 2 millimeters is what it is factory. I need to take it down to about 1.5 millimeters. Now, that dimension will vary just based on the small tolerances between how you build a cage and how I build a cage. You can see that the bulkhead there has some ability for adjustment of that motor plate. So I'm putting that spacer on a shaft with a bearing as a spacer just so that I can make sure I get down to where I need to, just to be able to hold it. Otherwise it can be really hard to hold a spacer that thin. With it sanded down to just about 1.5 millimeters, I was able to get everything in place. Just making sure everything spins in proper alignment, and then I'll go through and tighten that motor plate. If I tightened it when it wasn't in place, you have the tendency to add some bind to the whole system. I'll be using F10 portal axles for this build. That's what it was designed around. I'm also using the machined F10 portal housings and machined third members, and then the behind the axle mounts also are machined. Beyond that, I'm building the axles with the F10 portal axle sets. I'm also adding aluminum knuckles and brass portal box covers. Along with the top shaft, a pre-made link set is also available. This gives you all the 4-link suspension parts that you need. Steering links are not included with this link set. These links are specifically made for the F10 portals. If you use any other axle, whether or not the links will work is not something I can tell you. The brazen skid uses a set screw that goes in and actually holds the links in place, and then you use an M3 screw on the outside to hold the skid plate in place. This allows you to drop the skid without having to remove the links, which is super nice. I'm using Pricey's Customs shocks on this build again. I had 2 sets here. I was trying something else out. He's got an offset design that I was trying all around, and in the rear it kicked the shock at an odd angle, so I decided to go back to the standard setup that I ran with Pricey's before on this build. I am using the offset on the front shocks. This gives me a little bit longer shock as far as actual usable travel, but the overall length stays about the same. I'll also be using Maxxis Trepadors from Proline on this build and Vanquish Battleborn 2.2 wheels on this. Now, these are early production versions. These are uncoated. They will not be available in this uncoated fashion. You will only be able to get them in an anodized fashion. I also used GR8 scale hardware as well as the inner SLW bolts. The tire is a 1.9, the wheels are 2.2, takes a little bit of stretching to make things work, but not a ton of work overall. With this motor plate design, you can actually kind of get the gear mesh set pretty close with it outside of the chassis just to make things easy. As long as you pay attention to try and keep things lined up in a square fashion, this is a reasonably repeatable method that you can do, and your gear mesh will pretty much be the same once you drop it in the car. Just take your time and pay close attention to the alignment, and really not much hassle to it. Definitely easier to do it when it's outside of the car rather than when it's in this kind of funky configuration where the lower bolt is obscured by the transmission housing. For this build, I also decided to go with the SendCutSend panels. These are available. There'll be a link to all the SendCutSend stuff as well as the Jimmy's build package in the description below, but I picked up 5 sets of body panels so that I can have a number of different looks available. can't say that I necessarily know what I'm doing when it comes to doing any sort of like patina or weathering. I just thought that the 3D printed textures needed a little bit of contrast in areas to help it look a little bit more natural. And I think that my basic abilities helped it considerably. Whether or not it's much to speak of, that's a different story. Came up with this movable shift lever design. I had them cut out in both titanium and aluminum. For this build, since I'm using a lot of blue and red, because it's going to be themed in the end, I decided that I wanted the shift levers to be blue, so I'm going to use the titanium. This is just an ultra basic at-home anodizing technique that you can do with titanium. I'm using a power supply, but you can just use a series of 9-volt batteries and accomplish the exact same thing. Add more voltage and it will change the color. Experiment until you get the actual color that you want. I just kept going, went from a gold to a purple until finally I got the blue color that I was after. Wires getting into the gears was always a concern on this build for me, so I had made this little wire shroud just to keep things channeled in the proper area so I could kind of ease my mind of that. I decided to go with the standard style servo in this case. It is low profile, but it is not a direct power, so I'm using the Reef's Raw 800 LPs for steering on this one compared to the 900 LPs that I used in the previous. Still using the Raw 100 Mini for the shifting duties. Using a servo tester here just to center the servos initially so that I can make sure I put the horns on in the proper place without having to set and get my radio all configured for this specific car yet. I also like to use these mountable XT60 plugs. It just helps be able to maneuver inside of a tight vehicle without having to try and get both of your hands in there. Rather than using rod ends in this situation, since the servo arm and the shift horn move in the same plane, I can just use a very basic linkage in that case. It just saves me a lot of room. The Holmes Crawlmaster V3 has a BEC inside, but it's small. So I'll be running an external BEC, and because of that, I needed to remove the power wire from the servo wire lead that goes to the receiver. The Radiomaster receivers have a voltage telemetry lead that you can solder right onto the power wire side of any lead to give you voltage telemetry back to your radio. Here I'll be choosing the decal set that I'm going to put on this initial set of panels, and for that I'm going with a Red Bull theme on this car. That was the plan the whole time, that's why I went with the red-blue motor design. I also got a F1 steering wheel designed from Matt, and then I scaled it properly for my build, got it detailed up a little bit so that it looked more appropriate inside there. And now the build is 100% ready to run. Everything looks just like I hoped, and I'm super happy with the outcome. If you guys stayed around for this long, I appreciate you guys for watching. Hit the like button, subscribe, comment, consider joining channel membership, all available. Thanks again for watching.